Transmutation reactions, and transmutation means simply that it is a nuclear reaction, and the element that we see on the reactant side will be different than the element that we see on the product side. So if it's a nuclear reaction, then the end result is we change the identity of the element. Now, the type of nuclear reaction, the type of transmutation, it can be artificial or natural. So here we go. If it is a natural transmutation, the way that we tell, we only see one reactant. Versus if it's artificial, that means it's a forced process, and we will see two reactants. So take a look. Here is my arrow that separates reactants from products. To the left of this arrow, I only see one reactant. So since it's one reactant, I'm going to say that example A is a natural transmutation. When I take a look at example B, here's my arrow that separates products and reactants, and to the left of the arrow I see two things listed on the reactant side. So since it has two reactants, this is going to be an artificial transmutation. Now, taking a look at the clues in example C, I see there's only one line here, so there must only be one reactant. So this would be an example of a natural transmutation. And my last example here, finding the arrow to separate the products from the reactants. Here is a reactant plus another missing reactant. So I have two reactants, so I'm going to predict that this is probably an artificial transmutation. Besides classifying if a nuclear reaction is natural or artificial, there may be a particle that has been left out of the reaction, and we have to use clues to figure out its identity. So wherever there's a blank spot, we have to figure out what belongs there. So here is our big key, is that the total mass that we have on the reactant side needs to equal the total mass on the product side. So when you look at the symbol, so X would be the element's symbol, and then we have our numbers A to Z. Well, A represents the position of the mass. So when we take a look at example A, the only mass we see on the left-hand side is 212. On the right, we see there's a structure that has a mass of 4 plus the missing guy. So whatever is missing, it must supply all of the other mass, that when we add it to 4, the total is 12. So the missing structure's mass must be 208. We also need to take a look at the atomic number, so that's the lower number. And the atomic number represents the number of protons. So this information is not given, so we can find the atomic number based on the symbol on the periodic table. So when we look up PO, it has an atomic number of 84. And when it goes through this transmutation, He, let's look up its atomic number, which is 2 on the periodic table. He takes 2 protons with it. So we have a total of 84 protons on the left. He takes 2 with it. So the remaining, or the new atom that is formed, must have 82 protons. So now we can identify the new atom that is formed because its identity is based on the atomic number, 82. And on the periodic table, the element that uses atomic number 82 is the symbol Pb, or lead. So we're going to go ahead and solve letter B's example the same way. So if you take a look on the left-hand side, we have a mass of 9 plus a mass of 4, which gives us a total mass of 13 on the left. On the right-hand side, I only see one structure with a mass of 1. So 1 plus something will equal 13. So the missing structure must have a mass of 12. Now we've got to do the same thing for protons, or the atomic number. So I go to look at the periodic table. Be uses an atomic number of 4, and on the periodic table, He's atomic number is 2. So I have a total of 6 protons on the left-hand side. Now I have this structure. That is not the symbol of an element, but that's the symbol of a neutron, and I can look on table O for the atomic number. So if it's a neutron, according to table O, its atomic number is 0 because it has no protons. So if I take a look, I have a total of 6 protons on the left. This structure has none, so the missing structure must have all 6. So it has an atomic number of 6. So now I can figure out the identity of the missing structure by looking up atomic number 6. And when I look up atomic number 6, that is the element carbon, so we'll put a C there for its symbol. So now, looking at example C, we need to figure out the identity of the starting reactant. So I see a symbol here, Bi. It has a mass of 214. Then I see a weird symbol here. There's no mass numbers. So I know that this is not the symbol of an element, so I'm going to go to table O. And when I look on table O, this funny looking B with a minus sign means it's a beta particle, and the beta has no associated mass. So my atom here, mass of 214 plus the beta's mass is 0, so my reactant's starting mass must be 214. Now I need to do the same thing with the atomic numbers, or number of protons. So Bi is an element, and according to the periodic table, it has 83 protons. I need to go to table O to see how the beta particle affects the atomic number, and it has a -1. So 83 plus -1, my reactant must only have 82 protons. So now I can go to the periodic table and come up with its identity by looking up what type of element has 82 protons. And when I do that, 82 protons belongs to the element Pb. Last example here. I'm going to follow the same type of format. So I see that my reactant, one of my reactants is missing. So I'm going to start on the product side. I have one structure that has a mass of 12, another structure mass of 6. So the combined mass on the product side is 18. I do have one reactant showing that has a mass of 4. The missing reactant must make up the remaining mass. So I need to get to a total mass of 18. So 18 minus 4 is 14. So my missing reactant must have a mass of 14. I need to do the same process for the protons, or atomic numbers. So when I find Li on the periodic table, it has an atomic number of 3, so it has 3 protons. I find the element C, carbon, on the periodic table. Its atomic number is 6, so it has 6 protons. I also have this symbol, He, and helium, according to the periodic table, has 2 protons. So the Li and C are both products. Combined, they have 9 protons between the two of them. The reactant that is given to us has 2 protons, so my missing structure must supply the missing, or have the rest of the protons. So I need a total of 9. So 9 minus 2, my missing reactant must have 7 protons. So now I can look up the identity of the missing reactant. So when I look on the periodic table, the element that has an atomic number of 7 is nitrogen, so I can put a symbol of N right here. So be able to classify if the reaction, the nuclear reaction or transmutation is natural or artificial, be able to determine a missing particle's identity,